In 2011, the New York Yankees won 97 out of 162 of their baseball games. Is there sufficient evidence that the proportion of wins is greater than 0.5 at the alpha equals 0.10 significance level? So again, we want to start by writing down our null and alternative hypotheses. So again, the null h sub 0, and then our colon, and then h1 and our colon, and then we're talking about a proportion, right? Proportion. So p, and then it always equal to for our null, and that is 0.5, and they're talking about greater than 0.5, so greater than 0.5 for our alternative. So I'm going to underline important pieces here. So x is 97, n is 162, and alpha, our level of significance, also the probability of making a type 1 error, is 0.1. So we need to check our conditions here. So the main thing we want to check is that n times p naught times 1 minus p naught is greater than or equal to 10. So 162 times 0.5 times 1 minus 0.5. So let's check that in our calculator. So 162, open parenthesis, 0.5 close parenthesis, open parenthesis, 1 minus 0.5 close parenthesis, enter. So we get 40.5, which is greater than or equal to 10. So we are good to go with our hypothesis test. So again, we're going to use one prop z test. So stat, go over to test, and then number 5, and p naught is the p that's in our null hypothesis, so in this case 0.5. X is going to be 97, n is 162, and then our statement here is for our alternative. We're going to go over to greater than and hit enter, and then go down to calculate, just to make sure that that's highlighted. So let's write down what we typed in. So p naught is 0.5, x is 97, so you want to make sure you write things down like this on your test to make sure you're showing work. N is 162, and then our alternatives, so prop is greater than p naught. So go down to calculate and press enter. So our important information here is that z is equal to 2.514157444, and the p-value is 0.005965871. So now that we have our important values, we can go on into our p-value approach and then our classical approach. So p-value approach, we're going to compare the p-value to alpha. So remember, if the p-value is less than alpha, then we reject the null. So our p-value is 0.006, and alpha is 0.10. So our p-value is less than alpha, so we are going to reject the null hypothesis. There's our p-value approach. So we know we should get the same result from the classical approach. So again, we want to draw our region. So our alternative here was that P was greater than 0.5 and alpha is 0.1. So again, let's draw our region. So we just have one critical region and we're dealing with a look here, we're dealing with a right-tailed test. So again, we get that from looking at the alternative hypothesis. So we have a critical region, and that region there is alpha. So remember, alpha is what's in your critical region or region. So that is 0.1, so this is 0.9, and this is going to be Z sub alpha. So we can find that by doing inverse norm, and then our area to the left is 0.9, comma 0, comma 1, so second bars 3.9, comma 0, comma 1, and we get 1.28 there. So now we want to use or compare our test statistic. So our test statistic was 2.51. So 2.51 is greater than that, so it's going to fall in the critical region. So we are going to reject the null since our test statistic falls in the critical region. So now that we've drawn out that, we can see how we would compare that. So how would we write that out? We would say that our critical value is less than our test statistic. Or we could say our test statistic is greater than our critical value. And that's why we're rejecting. And so that it's easier to write that out if we drawn out the picture to show us that. So now that we've wrote that out, let's write out our final conclusion in terms of the problem. So since we're rejecting, that means that there is sufficient evidence. So the way to remember this is insufficient is not sufficient. So not sufficient, do not reject. So there is sufficient evidence to conclude the alternative. So in this case, there's sufficient evidence to conclude that the proportion of wins is greater than 0.5 at the 0.1 level of significance. It's always a good idea to put your level of significance. If we were to test that at a different level of significance, we may not get the same result.